minus 6. What did I just do? What is this, Eve? Michelle, I have your notebook up there. Did you grab it?
Yeah.
Okay, great. I took the derivative of the instantaneous velocity. What is the function? What did I take the derivative of?
T squared minus 16.
What is that? I see the equation, but what was this function? What is it? I took a derivative of a position function, and what did that give me? Velocity. S prime of t is v of t. Okay, does that make sense? And so if you physics people, have you guys seen some of this before? Okay. So some of you have, some of you haven't, and either way that's fine. Your velocity is equal to s prime of t. Now, what if I asked you now, what is the instantaneous velocity at time equals 0? What can you do? Plug in 0 to what? Into what? What function? My position function? If I wanted the instantaneous rate of change at 0, I can now figure that out by plugging in t equals 0 into my velocity or my instantaneous velocity function. And you get what? What does that mean? I'm going left 6 what? Potatoes? Feet per second. Change in position over change in time. Okay? You're going negative 6 feet per second. I'm going left 6 feet per second. Does that make sense, you guys? How fast am I going at 3 seconds? I'm not moving. If you plug in 3 into here, your velocity equals 0. What's happening on your graph? On your position graph? Yeah, I was starting at 8 and I was cooking. I was going left this entire time. Once I hit 3 seconds, I turned around. For that instant, just for that instant, I have a velocity of 0. Does that make sense, David? And then I turn back around. Okay? Now, can anyone tell me when I have the highest velocity or the biggest velocity? Or let me ask you this. When am I going the fastest? 0. At time 0, I'm going the fastest. Okay, anyone else? Why don't we do this? Why don't we graph my velocity graph here? V of t, which is equal to the derivative of the position function, is equal to 2t minus 6. Make a little sketch of this in your notes too. Let's take a little look at this little sucker. Okay, so down here, and we got something like this. And then at 5, this is 4. Picture on the interval, again, this is on the interval 0 to 5. Because then I get a little gassed. A good run, Mr. R. Way to put your time in today. So on the interval 0 to 5, this is my position graph, and here is my velocity graph. Okay? Instantaneous velocity graph. So, when am I going the fastest? According to this, looking at this picture, when am I going the fastest? T equals 5 seconds. I hear T equals 0 seconds. I hear 2. Any others? How many people think T equals 0 seconds? T equals 5 seconds. And then a lot of people just so frightened to answer that their hands are literally frozen. Well, what this mean? What does this negative 6 mean on a velocity graph? Left. What does this value here mean? What does at 5 seconds this 4 mean? At the 5 second mark, you're going 4 feet per second to the right. When are you going the fastest? Does that make sense, you guys? Again, the negative just means direction. Okay? What this gets into is speed. When you talk about speed, that's the absolute value of the velocity. So put that right there next to this, wherever you want. The speed is the absolute value of the velocity function. Speed equals bam. So you have this idea of displacement, which is just that final position minus initial position. You have this total distance where you actually have to count it. You have to be careful that you don't subtract. You see what I'm saying, Marco? Be careful when you count your total distance, because you might go backwards and forward. Think about like a sine graph. If that's your position graph, all you do is go backward and forward, backward and forward. So your displacement could be pretty much 0 depending on where you start and stop. But you travel a ton of distance as you go on. Does that make sense? Okay? That's the difference between displacement and distance. Average velocity, again, that's just going to be on an interval, your change in position over change in time at the end point. Okay? Instantaneous velocity is the derivative of the position function. And speed is that absolute value. So what is the speed at time 0? Speed is 6. What's the speed at 3 seconds? What's the speed at 5 seconds? Okay? And does that make sense, you guys? Okay, let me ask you this. When, according to this graph, am I speeding up? If I'm looking at this graph here. I got 3 answers already in the books. This is good. So far I heard, what did I hear? I heard 0 to 5, I heard 0 to 3, and I think I heard 3 to 5. What do you guys think? Anyone ready to justify? Yeah.
Between 0 and 3, your velocity is getting less and less negative, so you're approaching 0, like slowing down. And then after 3, you're getting 4 positive, so you're going faster.
Katie, I'm more of a visual learner. Can you run it off for me? At time 0, what's happening? With direction.
At time 0,
What are you doing?
slowing down.
This is, how fast are you going? Are you starting out going 0 or just like,
You're starting off going negative 5 meters per second, slowing to 0.
okay.
You start going positive faster.
Pretty weak if I do say so myself.
Well, you should.
Well, maybe I will. Is that a challenge? We're having a dance off now. All right. What happens here? According to this graph, you start out, Katie, you got to be cooking out of the gate. You know what I'm saying? But then you slow down. Why? Look at the values. You see the values? Your values get less and less. First you start out cooking. Negative 6 feet per second. You're going. I mean, you got to get those legs pumping. And then it's negative 5, and then negative 4, and then negative 3, and then 0. And then what happens at 3 seconds? You stop and what? You turn around because your velocity just went positive. And then you're kind of having fun. You're on the story going 1, and then 2, and then here we go again. Here we go. Do you see what's happening here, you guys? Does that make sense? That's what this is telling me. Even though what's tricky about this graph is it looks like it's all going up. You see it? But even though it's going up, the velocity started out as negative. So as the velocity is increasing, it's actually slowing down. Which gets into the next thing. Acceleration. What's acceleration? It's the derivative of velocity.